This is Kelly Hill, technology reporter for RCR Wireless News. I'm here today with Scott Sumner, who is VP of Solution Development for Accedian Networks. Welcome, Scott.
Hi, Kelly.
Hi. Now, we're going to be talking a little bit about small cell testing today, and I'm hoping you can give us a brief introduction to Accedian and what you folks do in terms of infrastructure testing.
Sure. So Accedian is a performance assurance specialist. We provide solutions that do monitoring, turn-up test activation, and optimization of wireless networks as well as wireline networks.
Okay, great. So let's talk about what trends you guys are seeing in the small cell market and how you're addressing those.
Well, I think the most exciting thing to us is we're starting to see some of the first outdoor deployments going nationwide here in North America, which is something that's been long time anticipated. And a lot of the technology that's following that, that's being developed along with the indoor space, is now moving into more challenging outdoor environments.
Okay, great. And so can you tell us a little bit about the role that you see monitoring versus discrete testing playing as we get more into this sort of HetNet environment with, with larger deployments of small cells?
Sure. Well, it's certainly becoming more difficult to gain visibility now that you're increasing the number of endpoints to so many of these small little endpoints that all communicate over the EPC in a mesh-style fashion with each other. So really just doing a turn-up test and seeing a single discrete point of time is not only not practical because the traffic's changing and the trends are changing and things are happening in between the towers so much, but it's also almost impossible to do now just because there's so many different sites popping up that it would be economically infeasible really to do a long-term test on every new access point you implement.
Okay. And in terms of, I know we're not maybe quite there yet with VoLTE and virtualization in small cells, but I think that we're sort of headed in that direction. And I'm curious if you could maybe talk a little bit about what you're seeing in terms of network testing in those areas and solutions that you guys have or directions that you see happening when it comes to those two things in particular.
Yeah, well, I think it kind of plays off the distributed sort of monitoring play versus discrete testing also in that area because the major Tier 1 operators that are planning these outdoor deployments of small cells are instrumenting them in a way so they can see the trends coming along, but also so that they can assess in advance whether VoLTE will work in certain markets and regions and over certain types of backhaul, for example. So the trick here is providing a way to do instrumentation that's cost-effective enough that you can leave it behind everywhere. Install it on small cells that may cost just a few $100s and make sure that they all can bring the data back and allow you to do network trending. So that's kind of where the NFV space has collided with instrumentation, where you get the ability to create basically virtualized instrumentation that's supported by centralized hosted controllers and very small amounts of hardware or just simply test agents and reflectors that are bringing back the data. And that allows you to actually reduce the cost of instrumentation by potentially up to 90% while allowing you to reach out over the whole network and see what's going on in these complicated head nets.
Okay. I want to ask one more question, and I feel like when we talk a lot about synchronization and how important that is to really making sure that small cells function correctly. Can you talk a little bit more about what goes into making sure that these new pieces of very small network elements are connected and synchronized properly with the rest of the network?
It's an interesting topic. It's also very difficult to test just because synchronization testing relies on clocking, which is inherently kind of a circular problem to solve. You're using clocks to actually measure it itself. And so one of the things you can do to prepare for this and make sure at least your transport and backhaul network are working is make sure that any instrumentation you have can measure extremely precisely in terms of latency and delay, and it can do that in a directional fashion. But I guess more importantly is that these devices or instrumentation has to be able to test between towers, between small cells and the macro cell, and between neighboring macro cells, so that you can actually simulate or monitor the traffic path that, let's say, PTP packets would take between these towers, and they're instead of just a central head-end probe that's looking in a hub-and-spoke model. That just doesn't apply when you're doing handoffs in these multi-head-net access point environments anymore.
Okay. Scott, any other thoughts on the market or small cell testing going forward?
Well, I think we're going to see there's going to be a lot of testing that involves a mix of different access points. You know, the macro cells, the small cells, the micro, the indoor, the overlapping coverage, and some sort of ability to optimize dynamically through a self-organizing network. It's the best way to get the signal to each individual UE. And I guess the problem here is just making sure that the view is real-time, fast enough, and these metrics are being fed into the proper controllers as they start getting rolled out. And that's really where the industry is at now. The mechanics of SDN, these controls are just starting to get tested out and testing the waters, and I think we have to be ready for that because the time is going to be necessary. It isn't too far away now.
Great. I've been talking with Scott Sumner, VP of Solution Development for Accedian Networks. Scott, thanks so much for your time.
Thank you, Kelly. Have a good day.